and welcome to the KU Community Webinar Series. I'm joined here by Dr. Samar Mohamed. Welcome.
Hello Jade, how are you?
So today we're going to talk about maths anxiety.
Yeah.
And I feel like the first question is, what is maths anxiety?
As a student, how did you feel about math?
I liked it.
Okay.
I did quite like it. I can't say the same for myself now. If I'm in a shop and I have to work out a percentage of something, I get that moment of, oh, I don't know if I can do this.
Oh, calculating the sale price,
Yeah,
right?
exactly,
Okay, yeah.
exactly.
This is always a problem.
Yeah, it is.
Yeah, so typically when you speak about math to students, when you mention math, they would say, oh my God, I hate math. So this is the first thing. And then the second thing, I cannot do math.
Okay.
And then the third thing, I'm too bad in math.
Oh.
So it goes this way. So the first thing is I hate math,
Yep.
and then I cannot do it, and I'm too bad in it. So it kind of elaborates and escalates in the same conversation, and you're not sure why. So
Yeah.
why do you have this feeling? Say, oh, I never did the math thing right. My whole life the teacher said I'm bad in math.
Oh.
My parents wanted me to get A in math all the time, and I never did it. I will never be a good kid. So it's always building and building and building. So math anxiety is real. Lots of people have math anxiety. I personally have family members and people who, and myself too, at the beginning, we always started with, I do not like math. It's problematic. Too many things to worry about, too many variables, too many graphs. Oh my God, what can I do?
Yeah.
So basically, no matter how many hours you study, you still feel that you're not comfortable. And I put 100 lines under the word feel because it's just your feeling. You're not bad in math. You have all the knowledge, but you just cannot focus enough and cannot have the great mindset to put you on the right track to solving math problems.
So it's not that you can't do it, it's that you feel like you can't do it because it
Exactly.
gets so complicated and there's so much going on, and all the way through school you've been almost taught to think, this is difficult, I can't do this.
And sometimes too, you're perfectly right, and sometimes it depends on what previous students have taught you before you come to class. So grade 3s are coming to grade 2s and you thought, oh, this is a horrible class. And so this is starting from the primary school and then going up and going up, and you have this initial mindset that math is hard. However, I never heard this about chemistry, while chemistry was too hard for me. But that's a different story. It's a personal life. So even though math anxious individuals think that they cannot solve the problem, they do have all the knowledge and tools that would allow them to solve the exact same problems in a different scenario. So let's say the student was at school under pressure, or on campus or whatever in class, in an exam, the most anxious point in life. They cannot solve the problem. Once they go home, looking at the same problem, they can solve it.
Yep.
So what is the difference between situation 1 and situation 2?
Stress.
Stress and consequences of doing it wrong,
Right.
and everything else. The most important part is anxiety takes over big part of your brain that is usually used to solve math problems. So when you go home, you're sitting at your dining table or whatever, your living room, sat and looking at the TV while solving the math problem, and you can do it right. While doing it in the exam room, you can't. So it is a mindset. So we need to actually work through the mindset and differentiate between I do have math anxiety or I'm bad in math. So these are the two things. The big problem is that people who are anxious about math, they avoid math.
Okay.
And when they avoid math, they do not practice.
Yeah.
Math needs practice. So then this leads to being actually bad in math. So the lie will turn to truth because of your anxiety.
And there's so many compounding factors as well. Not only are you not practicing, you're also hearing from everybody else that it's difficult, and that's just making it worse and worse and worse. And it builds as you grow older and go through school.
Yes.
To the point when you get into university and all of a sudden everything is maths.
Yeah,
It
exactly.
can be very scary.
Exactly, and especially if you are in a university that is well established and well known, like this university, most of the fields in this university involve math.
Yeah.
So it is a STEM university, and then you will have to take math at some point in life. Like it's either first and second year.
Yeah.
Physics use math. Engineering, then you're stuck with math for life. It's kind of. And also, you would not think before coming to university that you would use math in life. So why do I even take integration? Do I ever need integration in real life? Yes, you do, by the way. But when and where, you will know that later. You will know, you will have the toolbox with you wherever you go. And then whenever you need the screwdriver, you will find it. So this is kind of an interesting conversation that people can have with their kids and with their students. Do not think that you can ignore math. It cannot be ignored. It is part of your life. You need to calculate how much the shirt is after sale.
Precisely. Percentages come into my daily life all of the time, and I have no way of dealing with them.
15% tax, 5%.
I don't know.
Wherever you are, then there is different percentage for taxes depending on the country, and then you have to calculate the sale price, add to it the tax price.
Which always felt kind of unfair to me, to be honest. Why put that on the consumer? But anyway, that's a different topic entirely. But going back to that, what can I do if I'm stood in a shop? I've got percentages in front of me. I have no idea what I'm doing. I'm starting to panic. What's the first thing I should do?
So what people do that I do not like is they get their phones and use the calculator to calculate the percentages.
I wouldn't even know where to start with that, to be
honest. What I found helpful and useful to my daughter, said, okay, it's 20% discount. What is the 100%? 100%, okay? You have 20% out. Then what are you going to pay? 80%. Then you multiply this cost by 8 and divide it by 100, by 80%. So you multiply the $100 blouse by 8, then divide by 100, it will be 80. So you're going to pay 80. Instead of multiplying using the 20% and subtracting, then you're subtracting initially from the 100% and multiplying the difference. So it's instead of calculating the discount, you calculate the new price.
See, that sounds so reasonable, but that's something that was never taught to me at school.
Yeah, so this goes back to school, and then what can we do, and what is the reason of building this whole thing? So basically, I do not want to generalize, but mostly students in schools are learning math by memorization. So, okay, you need to memorize 2 multiplied by 2, 3 multiplied by 6, 8 multiplied by 9, memorizing all the time. So they thought initially it's engraved in their mind that math is about memorization, not about concepts. If the teachers spent more time in the primary school teaching kids that multiplication is not memorization, it is a concept, then they start building the habit of all math topics are concepts. So if we move up to different grades, you're talking now about different things, algebra, for example. So what is the concept behind this? Understand what you're doing this step. What I hear from students is that they are given a question bank, 100 questions. They solve these 100 questions. They go into exams, they find 1 or 2 or 5 or these 100 questions. So if they memorize the 100 questions properly, they will get 100% in the test. When they move on to university life, which is very different, they find that they get practice problems, yes, maybe more than 100. In the exam, they will find different set of problems that is similar enough with the same concept. But oh my God, I didn't see this before. This is too new to me. So it is not too new. It is just new numbers, new organization, new representation of the question. So let's say exactly calculate the discount in the shirt. This can be a question. The other question can be calculate the new price of the shirt. So these are the exact same question, but they are just worded differently.
Because you haven't learned that there is a technique to it. You've instead learned the way to solve one particular thing, and then you can't extrapolate from that to new problems.
Yes, exactly. You cannot scaffold things. So learning was not scaffolded. So they did not learn enough that multiplication is based on addition, and division is based on multiplication. And powers is also based on multiplication, and then square roots is also based on whatever. So it's always building on each other. So I was talking about that to my daughter. I said, okay, so we are studying now X topic. We need to actually study algebra first. So she said, but this doesn't have anything to do with algebra. But I said, no, it does, because we need to move up like items or variables around the equation sides all the time, everywhere. But we don't have algebra this year. So we're not covering algebra, we took it last year. So this conversation is happening all the time. Students try to divide math, while it is not divisible. Like math, you need to actually build and do not forget what happened last year. It's not a novel that I take this year and next year it's a new novel, then I forget about what happened in the previous book. Usually, I personally, as a student, one of my teachers, taught me how to solve math problems, and I really liked his method. I didn't know that it's an actual method that is published in research afterwards, but I knew now. So it's called the GRASS method, which is write all the given, write all the requirements.
Okay.
What can you do with these givens? Can you draw a graph? Can you put a table? Can you put some correlation with things? Can you, what is the analysis of what you have now? After you analyze, you develop a plan for the solution. When you develop the plan for the solution, it might not work because the initial plan might not work. There is not single one solution for lots of problems. You can have your way of solving it, my way of solving it, and we all reach the same correct answer. Students are not convinced of that. So students think that they do have to have one solution instantaneously correct.
And there's only one way of getting it.
And there's only one way of getting it. So I got the problem, I'm solving it now, I have to get the right answer now, and I have to do it correctly from the first iteration. There's no going around and trying to fix it. If you cannot do that, then you're bad in math. That's the insight that they have. And this is all caused by peer pressure. So the student will ask a question, the class is asked the question by the instructor or teacher, and you will find 3-4 students answering the question all the time, the same 3-4 students.
Okay.
The rest of the class is intimidated because they feel, oh my God, then I'm stupid. Everyone else is able to answer the question, but I cannot. So they are always comparing themselves to their peers. This is a challenging part. You do not compare yourself to anyone. Everyone has their own pace of doing things. So not that you did not reach the first place in solving the problem, then you cannot solve it. You can solve it at your own time. So take your time, think about the problem, take your time again, ignore everything that's happening around you, and then focus on your work. So it's, I know it's hard, and it needs to start early in life. Because avoidance and anxiety are snowballing. So you're anxious, you're avoiding, then you're not doing well, you're more anxious, and you're doing more avoidance, and so on and so forth. So it is not,
Where then can teachers and instructors step in? Can they go in from that very early stage and start teaching the idea of a concept behind it? Because at the same time, that's kind of difficult to do for young kids, for example, when you're trying to get them through school and get them to the higher stages. But I suppose you've got to start super early with encouraging them to do maths and to enjoy it and to find the ways to solve things.
So teachers are a great resource. And they need to be patient, and they are. Like most of our teachers in university and in school, and instructors and faculty members, even in graduate school, my supervisor was very patient with me. So being patient is a skill. So they need to be able to support the students the way that they need. In the same class, you will have all levels of math abilities and all levels of math anxieties at the same time. So knowing your students is one important thing. So for example, if I know as a teacher that there are, or an instructor, it happens at all ages, so we cannot really separate. It's much better to start early, but it's not guaranteed.
Of course.
So it's, you never know, as a faculty member, you never know what happened to your students 12 years ago. So it's, you also need to start at some point. So when you know your students, we are lucky here in Khalifa that the student to teacher ratio is really good. So the university that I came from, we had the math class with 300 students sitting in the same room. My daughter was in one of these classes in the faculty of math. They did great, all of the students, by the way, but they were overly stressed all the time. While here you can find 30 students per class, so the instructor, or per section in the class, so the students can feel that they are important, and the instructor can build this relationship with the students, so they can know who is the anxious student. While they're doing that, the students are solving a problem in class, for example, the faculty member or the teacher can go in near that student and say, oh, you did it right. Your trials are all great. This is perfect. Why don't you raise your hand when I ask for the answer? And then when he will give, typically teachers are supposed to give time. So they'll say everyone in the class, no one raises their hand before 2 minutes, for example. So that the anxious students do not feel that they're pushed to finish early and to compete with the ones who are just raising their hand all the time.
Remove that level of pressure.
Exactly. One layer, a simple layer, one of them. There are so many layers, but remove one, which is the time. And then move near them while they're solving the problem and try to encourage them. You did this part right, perfect. But you know what? We can work on that part. There is a different solution that can be better than that one, and so on. So help them to get to the right answer. Once they get to the right answer, ask them to raise their hand and choose them. So you build their confidence. Because usually practice and confidence will lead to better performance in math. You need confidence. Also, teachers need to give the students the growth mindset. So we are not able yet to solve this problem. It's much better than we cannot solve this problem. So just very simple change in one word in the sentence can help the student. So if a kid comes home and say, the teacher said I can't solve this problem, then he will have this mindset. I will never be able to solve the problem. The expert said I cannot do it, then I cannot do it. But if he gives them the chance and the opportunity and the practice time to try and give them feedback, instant, timely, constructive feedback. So feedback needs to be timely, constructive, and attainable too. They can do it. So the feedback cannot be go review 10 chapters of math and come back to solve the problem. So it's kind of something that can be done. They can also have to reinforce that mistakes are okay. It's okay to make mistakes. We do mistakes. We all learn from mistakes. If I have not burnt my first cake, I would have never baked a cake in life. So it has to be burnt first time. It has to be raw second time, and the intermediate in between, good one, will appear at the end. So it's a cycle of building things and scaffolding information, accepting to be wrong, listening to feedback, and giving feedback also to teachers. So teachers can also invite each other, their peers, to come to their classrooms. For example, okay, Jade, why don't you come to my classroom and observe my teaching and let me know if I'm handling stressed students properly? Or what do you think? Because sometimes an external eye sitting in the room will give you honest feedback on what's happening. So so teachers and faculty members for sure have big responsibility on helping these kids. Also, they can provide students with hands-on experiences so that, for example, you have this equation, try to move the objects or the items in the equations around. So put the x in the place of the y and the y in the place of the x, then what's happening to the signs, or what's happening to the fractions, or what's happening to the percentages. And so when they see it, maybe in simulations or in online textbooks that we all have now in KU, then you can go in and practice problems, moving things and seeing the right answer and knowing what can be better. So it's practice, low stakes practice, please. So not every assessment needs to be graded for high stakes. They need to get practice and to know that this is a safe environment to try. If I mess this up, I'm not failing the course. So these are little tips, and we can discuss further for sure.
For a student who's come in, they're about to sit their final exam, they've been practicing, but they've still got that bit of exam stress. What would be your final tip for them just before they walk into that exam?
So they should think, I know it's hard, and I acknowledge it's hard, but use 5 minutes of the exam time at the beginning to do some relaxation techniques. So breathing, breathe deeply, think about your breathing. Or the CBT methods, like the cognitive behavioral therapy methods that are being used by psychologists all around the world. Think about one thing you can see. So for example, I see this tissue box, it's black with white thing. Nothing to do with the exam. One thing you smell, I smell the coffee that they just had now without having coffee myself, but that's okay. One thing that you touch, for example, I touch the chair, it's a little fabric, whatever. So think about your senses, focus on yourself, breathe, take your time to think. Most students jump to right answers in 1.4 seconds.
1.4 seconds.
While the average is 10 seconds for the easy questions to be started. So for the brain to process an easy question, 10 seconds. Why do you write in 1.4 seconds? Like it's research based. It's nothing that I came up with. So you need to take time. You need to think about yourself. And you also need to think about the GRASS method. What is given, what is the required, how can you analyze, how can you formulate your solution, and at the end you write a closing statement. So the area of the rectangle is 1.4 meters squared. This is the closing statement of calculating the area of the rectangle, for example. So think of, so that your instructor, your teacher feel that your solution is complete. You started by putting what you know, what you need, how are you going to solve it, the solution, and the final statement. Even if you miss any part or do it wrong in between, the teacher and the instructor will pay attention or will know and will acknowledge that you know the right pathway. So this will make their life easier, the teachers, and this will make your life easier in terms of confidence. And start with what you know in the exam. Don't start with the first question. Scan the exam first, see the question that you're more comfortable, the topic that you practiced more, start with it. And this tip helped me and my kids all the time, and my students too.
Dr. Samar, this has been so helpful.
Thank you very much. It's nice talking to you, and you had a very big contribution to the conversation by the great comments that you made. Thank you very much.
Thank you.
Thank you.